I'm going to tell you guys the same thing I told pre-algebra not very long ago. I am filthy, I haven't showered, and as you can probably tell, I haven't changed clothes in 24 hours. I'm dirty, I stink, I'm gross. Well, I may be gross, but I'm actually not dirty. And it hasn't been 24 hours. I'm recording 4 math classes. I'm proud of that one. Back to back to back to back. One more. But no, the reason I'm doing that, a couple of things. One, just like I told pre-algebra, this that we're doing right now is so easy. No big deal. It's not going to take really, I don't think, that long to go through it. And the other thing, to be really honest with you, is I want to go fishing tomorrow night. I'm not skipping out of school hours. I will still be available during school hours, but I, the good Lord willing, am going to be doing some white bass fishing on a creek tomorrow evening. And this frees me up to be able to do that because I usually record my lessons at night. Again, still available during school hours, so please contact me during those. And a lot of times I'm also try my best, to get back to you as soon as I can, like I do, as soon as I can, even outside of school hours. But let me know during school hours for sure. Any questions you have, if you could use some help, guys, I'm here for you. And so just let me know if I can help out and how. I'm always glad to do that. And just to make sure you understand, after school hours, I'm glad to help you too. It's just a lot of times, and it's usually not because I'm fishing, I assure you. But usually it just takes me, because of my other job, a little bit longer to get back with you. Okay, so let's move on to radical equations. These guys are really easy. They're going to be a breath of fresh air from what we've been doing with radicals. I think you'll be grateful just for how simple they are. So what we're going to do is solve equations. We're going to be solving equations when they have a radical involving the variable, and that variable is a part of, or maybe entirely, the radicand, meaning the term underneath the square root symbol. How in the world do I solve whenever it's that way? Okay, let's give the first one a shot. This is as easy can be. I have the square root of x equals 10. Wait a minute, that's already done. Not quite, right? I'm not trying to solve, guys, for the square root of x. I'm trying to solve for x. But if x is having the square root of it taken, how do I get rid of that square root? In other words, what is the opposite, or what's the inverse operation of a square root? That is something that is squared. Okay? Because when I square, that's the opposite, remember, of a square root. It's so obvious we don't write it in. But see how those numbers are the same, just in an opposite way. And so that gets rid of those, and that's going to give me just the variable x. But what I do to one side, Anna, I have to, good girl, do to the other side. So just as I squared that square root of x, I have to square the 10 that's found on the right side of the x. And so what is 10 squared? Anybody know? 10 times 10 is, of course we know that one, that's one of the easiest of all. We like multiples of 10 when we're operating in the base of 10, as we do in our culture, because that makes it simple so as just to add a 0 to the end of it. 10 with a 0 is 100, x equals 100. Now here's something though that's a little bit different. You might look at that and say, are you kidding me? That's like maybe even pre-algebra. Kinda. But there's a little more to it. When you take, or when you have originally a square root, and you solve for that by squaring the radicand that involves the x, you have to go back and check your answer in the original equation. The original equation was the square root of x, which we've now found to be what? 100. So I'm going to rewrite the original equation without the x and just with the solution we found for x. So the square root of 100 equals, the original equation was, in black, just the number 10. Guys, what is the square root of 100? What times itself gets me to 100? Just the number 10. And so what I have, the square root of 100 is 10, and then equals, just bring down my 10. Does 10 equal 10? Aha! So I have an answer. I know, yes, that is correct, that x truly does equal 100. You might say, well, of course it does. And I could have told you that from the beginning. So why did I do that and check it? Stay with me. There might be a reason. Okay, number 2. 8 plus the square root of x minus 3. Well, this is kind of cool. Now we have a number attached by addition or subtraction underneath the square root symbol with the x. We haven't done that yet. 8 plus the square root of x minus 3 equals 4. How do I solve this? Okay, first things first. You see this number, it's a positive 8 sitting out there all by its lonesome. I need to get rid of that from that side so I can almost, not quite, but almost isolate my x. But what I can isolate is the radicand, which is the terminology, if you will. It involves the expressions, plural right now, underneath the square root symbol. But the first thing I have to do to isolate that is get rid of what's detached from the entire square root process, and that is a positive 8. How do I get rid of a positive 8 that's just sitting there? I subtract, of course, both sides by 8. Okay, and that gets rid of it on that side, right? I'm not going to cross it out, so we've got to go back and check in the end. So, but we understand that cancels it out. Okay, so that with which I am left is a positive x minus 3, under a square root symbol, of course, equals, guys, what is 4 minus 8? 4 minus 8. That is negative 4. Okay, now watch this. I have the square root of x minus 3 equals negative 4. I can't do anything else until I get rid of that square root symbol. How do I get rid of a square root? I square something. And I have to square, guys, everything that's underneath that square root sign, not just my x. So the entire thing becomes squared. And what you do to one side, Carter, you have to do to the other side. I don't know if you answered me, Carter, but you better. That's a respectful thing to do. Okay, so we have these cancel each other out, the square root, okay, and the square. It's understood square root, but those numbers, they're the same, but inverse operations. So they cancel each other out, just leaving x minus 3, which is wonderful, because that's the way I want it to be. Life is good now that I don't have a square root symbol. But because of that, I have to square what's on the other side. What's negative 4 squared? That's not negative 4 times 2. That's negative 4 times negative 4. Two negative numbers give me a positive number, and 4 times 4 is 16. Okay. Now, how do I solve, guys, from this point? X minus 3 equals 16. The way I solve is isolate my x by adding. Okay, adding 3 to both sides. And I will cross out there because I don't need that in the end. X equals, what's 16 plus 3? 16 plus 3 is a fairly large, compared to our previous one, an answer of x equals 19. Okay, now what I have to do though is I have to go back and check whether this is the case. Does x truly equal 19? I think I have enough space right here I can try it, so let's try it right there. So I have x, or I'm sorry, not x, 8. Yeah, it starts with the same pronunciation, doesn't it? So I was thinking, how did I get that? Okay, so I have 8, that's my original equation, plus square root of, okay, what I find x to be, 19, so I put 19 in for my x, minus 3, and that's still under the square root symbol, okay, and then equals 4. That's my original equation. The only difference is what I found x to be right down here, I plugged that in 4x. Okay, so I have 8 plus square root of, what is 19 minus 3? Obviously, 19 minus 3 is 16. That's a pretty simple one. Equals 4. Okay? What is the square root, guys, of 16? What times itself get you to 16? The numeral 4. So 8 plus 4 equals 4. What's 8 plus 4? 8 plus 4 is 12. Bring down my 4. Wait a minute. Does 12 equal 4? No, 12 doesn't equal 4. So guess what? The 19 that I found x to be is an imposter. It's a bogus number. It's not real. That's not a true answer, and that's why you check. That's why you check. What am I trying to say? Equations. There we go. That's why, guys. Again, it is late. Trust me. That's why you that's why you test. If I can spit it out. That's why you test equations that have x or y or z, whatever it is, a variable underneath the square root symbol. It's a part of the radicand, because sometimes you'll come up with an answer, but then you go back and you plug it in and you check it, and it's not 0 that's the answer, but it's a 0 with a line through it, which means, and you know this, no solution. Okay? Don't stop at x equals 19, or you just got minus 1 on that problem. So the true answer is no solution. That's why you got to check. So let's try just a couple more, and we'll call it good for not only the day, but also the week. Number 3, square root of 2x plus 5 equals 8. Okay, square root of 2x plus 5 equals 8. Guys, I can't do anything in this one until I get rid of the square root symbol, because I have to isolate x to solve, but whatever I have attached to x on the left side is a part of the radicand. And so what do? To get rid of the square root? We put that sucker in parentheses, and we square that dog. Okay? But whatever we do to the left side, we also have to square that 8 on the right side, don't we? Okay. Well, the reason for my squaring the square root, the reason for my squaring that is, well, let's just cancel each other out. And I'm just left with 2x plus 5 equals not 8, but 8 squared. What is 8 times 8? If you said 64, you are on your way to becoming a genius. Not really. That's like what? 4th grade, maybe even 3rd grade math. So, but that's good though if you said it. That's still a solid thing. Better than the alternative. So 8 times 8 is 64. How do we move on from this point? Two-step equation. Therefore, everything I know is wrong. Up is down, left is right, and short is long. So, I have a positive 5. I do addition or subtraction first. The way I get rid of a plus 5 is I toss in a minus 5. And what I do to one side, I have to do to the other. And these two are going to cancel each other out. And that with which I am left is, I'll write this over here to give some space for later, 2x equals, what is 64 minus 5? Hope your brain's working sharper in the morning hours than what mine is late evening. So what I have is 2x equals, what's 64 minus 5? 59, homies. Okay, and I finish solving, of course, by dividing both sides by 2, and x is going to equal. Guys, a fast way of doing this in your head, there are a couple ways. I like the fastest way, which is this. If you were to round that 59 up to a 60, a 60, 2 will go into 60 how many times? 30. But because it's 59, it'll go in 1 less than 30 times, which is 29, and it's going to have a remainder of 1. And since you divide it by 2, your denominator in that mixed number is going to be a 2. It's kind of a quick, easy way of doing it, isn't it? So 29.5 would be your solution to x. Okay, now what I need to do is go back and test it, because we've already found out sometimes it works and sometimes it doesn't. The only way you know is whenever you test it. So what we're going to do is go back to the original equation, which is the square root of 2 times x, which we found to be what? 29.5. And instead of 29 1/2, are you comfortable if I put 29.5? I like decimals, dealing with them, especially multiplication, better than I do fractions and mixed numbers. So 2 times 29.5, okay? And then plus 5, all of that, it's a big long one, isn't it? It's underneath the square root symbol, equals, hopefully, 8, unless we need to change our answer. Okay, 2 times 29.5, well that's easy. Look, we divided that original number by 2 to get 29.5. So if we multiply by 2, we're going to go right back to where we were, at 59. So square root of 59. Don't forget your plus 5, and all of that is the radicand, which is the terminology underneath the square root symbol, equals 8. Okay, let's simplify. What is 59 plus 5? Look at that, we're working back to where we were before, aren't we? We subtracted 5, we divided by 2, well, here we multiplied by 2, and we added 5, the opposites of those, to get us right back to 59 plus 5 is 64, equals 8. All right, what's the square root of 64? 8 equals what I have on the other side, 8. Is that true? Sweet. So we are good right here with this answer. My answer is not 8. Remember, my answer for x is 29.5. And when I checked it all out, it came up to 8 equals 8. When I checked over here, it came up to 10 equals 10, but that doesn't mean 10 is my answer. My original answer for x equals 100 is the correct one. And therefore, x equals 29 1/2 is the correct one here. It's just 8 equals 8 is what helped me to determine that. Okay, let's do one more. Numero quattro. Mi amigos and amigas. So, we have 10 minus 2 square root x equals 7. So, what do I do first, guys? This is almost, not quite, but pretty close to a two-step equation. Technically a 3, but they're a little different when you're dealing with square roots. Whatever is in that square root term, which is -2 square root x, don't want to deal with that until the very end. That with which I want to deal is what's detached, but still involved with it. And what that is a positive 10 that's sitting right there. And so how do I get rid of what's understood to be a plus 10? I do a minus 10, which is going to cancel that out. I won't do, because we're going to go back and check in the end. I won't draw a line through it, that is, even though we understand it's canceled out. What I do to one side, I have to do to the other, minus 10. So I have -2 square root x equals -10. Okay, I want to do everything I can without touching what's inside that square root until the very end. I have a -2 that's being multiplied to. It's not inside of like it has been in the others, but it's being multiplied to that square root where the x is found on the inside. So if it's being multiplied, how do I undo that -2 that's finding itself multiplied to the square root symbol and what's underneath? I divide both sides by -2. Cancels out over here. I have square root of x equals, okay, what is -10 divided by -2? Two negatives make a positive in math, and 10 divided by 2 is 5. And how do I get rid of a square root symbol? I just slap parentheses around that sucker, square it, because that's understood to be a square root. See the numbers that are the same, but inverse operations. What I do to one side, have to do to the other. And so x will equal, what's 5 times 5? 25. Okay, now I go back with that information, plug it into my original problem, and see, does that check out? 10 minus 2 square root, instead of x, what I found x to be, 25 equals 0. Okay, let me simplify. When I'm working this way, allow me to simplify what's inside of that square root symbol. It's kind of like parentheses, square roots are. And so they would come first. 10 minus 2. Okay, what's the square root of 25? 5. And I said it's kind of like parentheses. See, when you simplify it, it is parentheses because you're multiplying that by it. Equals 0. Okay. 10. What's negative 2 times 5? Negative 2 times 5 is negative 10. What's 10 minus 10? 0 equals 0. True statement? Mm-hmm. So, my answer, guys, is correct. X equals 25. And BTW, normally you're going to find that the answer does check out. I would say it's going to be very similar to the ratio that we have right here. Probably about 1, roughly, in math homework and tests. Probably about 1 in every 4 or 25%, a quarter of the time. Probably you're going to find to be no solution. But normally you're going to have an answer with which you come up. Okay, guys. This is the end of section 8, and is typically the case at the end of even sections. Guess what I have to assign for the weekend? Homework. Love you, though. No, I really do. But it is what it is. But guys, we are so close. Do you realize that we only have one new section? I know your syllabus reads a little bit differently, but through the teachers' meetings and the admin recommendations, we're making some amendments to for those of us who had planned a ways out already. You only have one section, one new section, I should say, of math left for the entire year. Before we review, we'll have that last first section on Monday. We will review on Tuesday, and I'm going to give you 2 days to take your test. I think that's plenty fair, and that you guys can use it. You work hard on them, and I appreciate that you don't give up easily. So I'm going to give you 2 class periods instead of trying to cram it into one, or you have to work overtime on Wednesday and Thursday to finish up that test. But for the weekend, guys, if you want, you can go ahead and get your homework done. It's to your advantage to do so. However, you do have until Tuesday, 2 class periods Tuesday to turn it in. Regardless, guys, I hope you have a great weekend. Relax a little bit, and if it's sunny, man, wouldn't that be nice? Go soak up some rays, you reptilians. I'll see you guys.